Hey there, cloud enthusiasts and machine learning aficionados. Welcome to what could have been just another boring lecture about IAM roles and policies, but I promise it won't be that. All right. I am Ibrahim Malik, your AWS certified guide through this security maze today. Whenever I mention IAM at parties, people either think I'm having an existential crisis or they suddenly remember they need to refresh their drinks. Okay. By the end of our time, you'll be the cool one at the tech meetup dropping IAM knowledge bombs that will make even the most seasoned cloud architects nod in respect. Okay, so buckle up as we dive into the thrilling world of identity and access management for ML workloads. And yes, I just used thrilling and IAM in the same sentence. That's how we roll today. Let's make security fun, shall we? All right, let's talk about AWS Identity and Access Management, or as I like to call it, the bouncer of your AWS nightclub. Okay, IAM is the strict but fair security guard deciding who gets VIP access to your precious ML data and who's left standing outside in the rain, right? You know how in the spy movies there's always that upper secure vault with retina scanners, voice recognition, and whatnot? IAM is basically that, but for your machine learning workloads. Except instead of Tom Cruise dangling from the ceiling or break in, it's probably Bob from accounting trying to access training data he shouldn't. But seriously, why should we care about IAM in machine learning? Well, imagine training a revolutionary AI model on your top secret data, okay? Only to find that everyone in your organization has been using it as their personal playground. Yep. Okay, here's a quick story. A friend of mine, I heard it from a friend, once worked with a company that they had their groundbreaking product recommendation algorithm accessed by an intern who thought it would be cool to tweak some parameters. Let's just say their customers suddenly started getting recommendations for underwater basket weaving supplies, regardless of what they actually browsed. So, not exactly the personal experience they were aiming for. So, IAM it's not some, boring compliance checkbox. It is what it stands between your brilliant machine learning work and potential chaos. It's like having a really good lock on your front door. You don't appreciate it until the day you realize someone could have just walked right in and stolen your TV, or in our case, your precious training data and models, right? All right, so let's talk about the key concepts. Let's break down IAM into digestible pieces. Kind of like how I break down a complex pizza order, right? Methodically and with attention to detail, one slice at a time. First up, we have IAM users. These are individual AWS accounts, like your personal login. Think of them as individual keys to your AWS kingdom. Just like you wouldn't give your house key to a random person on the street, you shouldn't create IAM users without thinking about what they need access to, right? Another tidbit, right? Once I had a client who created a new IAM user every time someone needed temporary access. 6 months later, they had more unused IAM users than actual employees. It was like having a key rack with 200 keys and not remembering what 190 of them were for, right? Security nightmare, of course. Next, we have IAM groups, which are collections of users. This is the work smarter, not harder approach to permission management, right? Instead of assigning the same permission to 50 different scientists one by one, right? You create a data scientist group with the right permissions and add users to it. It's like, creating a Spotify playlist instead of selecting the same songs every time you want to work out. Okay. Then we have IAM roles, which are like temporary backstage passes for AWS services. Roles are my personal favorite because they don't have permanent credentials. They are temporary, like the diet I try every day, right? Here is a real world analogy. IAM users are like employees with ID badges, groups are like departments, And roles are like those temporary visitor passes that expire at the end of the day. Okay. So except in AWS, the visitor might be an EC2 instance, right? Or a Lambda function trying to access your S3 data. Finally, we have IAM policies, which are JSON-based permissions, right? If you're not familiar with JSON, don't worry. It's just a way to structure data, kind of like how a recipe structures ingredients and its steps. So, except instead of resulting in delicious cake, it results in precisely defined permissions, right? There are two types of policies: managed policies, which are predefined by AWS or your administrators, and we can be attached to multiple users, groups, or roles. And inline policies, which are embedded directly into a single user, group, or role. Think of managed policies, right, as restaurant chain recipes that are standardized across locations, right? While inline policies are like your grandma's secret recipe that she only uses for special occasions. Okay? Now I know what you're thinking. This is all pretty dry stuff, but trust me, understanding these concepts is like knowing the basic moves in chess. Once you get them, you start playing the game at a whole new level. All right, so let's talk about IAM roles in machine learning, right? Now that we have covered the basics, right? Let's talk about how IAM roles show up specifically in machine learning work. It's like a Marvel movie where each superhero has their specific powers and responsibilities, right? Except instead of saving the universe, we're just trying to build and deploy models without security incidents, right? First, we have the data scientist role. These folks need read-only access to data sets, but probably shouldn't be able to delete production database, right? I heard of a story of an organization that gave their data science team admin access because it was easier than figuring out proper permissions. Two accidentally, two accidentally deleted S3 buckets later, they realized that easier isn't always better, right? It's like giving a teenager the keys to both the car and the liquor cabinet. Technically efficient, but practically questionable, right? The machine learning engineer role needs permissions to train and deploy models. This role needs more access than data scientists, but it's still within limits, right? They need to spin up training instances, access specific S3 buckets, and deploy models to endpoint. But do they need to be able to modify your organization's VPC settings, right? Probably not, unless you enjoy unexpected network outages, right? Here's another funny real world story. I've heard that, friend worked with a client whose ML engineers couldn't understand why their models weren't deploying properly, right? After hours of debugging, they realized they had permissions to create endpoints, but not to access the ECR repository where the Docker images were stored. So, it's like being allowed to drive a car, but not having access to the gas pump, right? Then we have specialty roles, like the S3 read only role. S3 read only role, right? Which is exactly what it sounds like. The role can read data from S3 but can't modify or delete it. It's like letting someone look at your family photo album but not letting them draw mustaches on your baby pictures, okay? And let's not forget the Lambda execution role, which determines what your serverless functions can do. This is especially important for inference endpoints that need to process real-time predictions, right? The Lambda roles needs just enough permission to do its job without creating security holes. It's like hiring a valet to park your car. You want them to have the keys, but you don't want them taking a cross-country road trip with your vehicle, right? I once saw a Lambda function with full admin access. It could literally do anything in the AWS account. The developer's justification: I was tired of getting permission errors. Just like, burning down your house because you were tired of the smoke detector going off while you cook, right? All right, moving on. So, how do you manage permissions, right? Let's talk about one of the most important principles in security: least privilege. This fancy term simply means giving users and services only the permissions they absolutely need to do their jobs, right? Nothing more, nothing less. Like letting your teenager borrow the car to go to school, but not giving them permission for a spontaneous road trip to Vegas, right? In the context of machine learning workloads, this might mean limiting access to specific S3 buckets containing training data, right? Rather than granting access to all S3 buckets in your account. You know, it's shocking how many organizations I've worked with that give blanket S3 access because it's simpler. Sure, it's simpler, and so is leaving your front door unlocked, but that doesn't make it a good idea, right? Now let's look at this example. I am policy, you know, I'm showing you a snippet, right? That don't let the JSON syntax intimidate you. Okay. It's actually pretty straightforward once you break it down. The effect being allow means you are granting permissions rather than explicitly denying them, right? The action specific the action section specifies exactly what operations are permitted. In this case, getting objects from S3 and listing bucket contents, right? The resource section defines exactly with which S3 buckets these permissions apply to. So let me translate this policy in plain English. Hey AWS, please allow whoever has this policy to view and download files from this specific machine learning dataset bucket. But don't let them change anything or access any other buckets. See? It's easy, right? A friend once told me a story that he audited an organization's AWS permission and found a data science role that could literally do anything with any service in their account. When I asked why, the response was, well, we didn't want to slow down innovation. That's like saying you removed all the guardrails on a mountain highway because you didn't want to down the traffic, right? Another classic example I've seen is granting access to ARN AWS S3, right? Which is essentially saying have fun with all of our S3 buckets. Okay. This is fine if your intention is to give someone the keys to your data kingdom, but usually it's just an oversight that creates unnecessary risk, right? Let me share a quick analogy. Imagine your AWS account is a large office building. Least privilege means that the cleaning staff has keys to the rooms they need to clean, but not to the CEO's office or the server room. IAM policies are those specific keys, okay? Determining exactly which doors someone can open and what they can do inside, right? The more specific your policies, the more secure your buildings, or in this case, your machine learning data and infrastructure. All right, let's talk about SageMaker, one of my favorite topic, right? IAM for SageMaker, it's like the Swiss Army knife of machine learning services on AWS, all right? With great power comes, of course, great responsibility, and SageMaker has a lot of power. The SageMaker execution role is the backbone of your machine learning operations. It allows SageMaker to interact with your AWS services on your behalf. Think of it as your personal assistant who has permission to access your email, calendar, and bank accounts. Hopefully, a very trustworthy assistant. This role needs permissions to create and manage EC2 instances, right? For training and hosting. Accessing S3, right? For data and model artifacts. And possibly other services like CloudWatch for logging. But here's where people often go wrong. They attach the Amazon SageMaker full access policy and call it a day. That's like giving your assistant the master key to your house, office car, safety deposit box, right? And the secret candy stash as well, right? Do they really need all of that? I hope not. Okay. I once helped a company debug a SageMaker issue where their notebooks couldn't access their data. After digging, we found that they had correctly given SageMaker access to the S3 bucket, but forgotten about the KMS key that encrypted the data. It's like giving someone permission to enter a room, but forgetting to tell them about the retina scanner at the door. For notebook instances, you might want data scientists to have the ability to create and use notebooks, but not to modify the underlying infrastructure. For training jobs, you need permission to access training data and save model artifacts, right? But perhaps not to modify the VPC configuration. Okay. Fun real world example. Uh, a company, a client of mine set up their SageMaker environment with a role that could access production data but couldn't write back to it. Okay. They thought this was secure until they realized the role could create new S3 bucket and EC2 instances, which led to someone accidentally spinning up a fleet of expensive GPU instances for an experiment and forgetting about them over a long weekend. So Monday morning brought a financial surprise that was definitely not in the budget. When it comes to model deployment, you might want to limit who can deploy models to production endpoints, as opposed to development or testing endpoints, right? This is like having different levels of authority for pushing code. Interns might push to the development branch, but only senior engineers can push to production, right? In one memorable case, a well-meaning data scientist deployed an experimental model directly to production because the accuracy looked really good in my test, right? Unfortunately, they hadn't considered edge cases, right? Data drift or computational efficiency, all things that would normally be caught in proper review process. So having the right IAM instructions in place could have prevented this premature deployment and saved them from some very confused customers. All right, let's talk about the best practices, right? Beyond IAM roles and policies, there are additional security layers you should add to your ML Fortress. It's like how a good home security system isn't just a steady front door, right? It also includes window locks, motion sensors, and maybe that dog that barks at everything, right? First up, data encryption. AWS Key Management Service is your friend here. Encrypting your S3 data is like putting your sensitive documents in a safe rather than just a drawer. Even if someone somehow gets access to your S3 bucket, encrypted data is just gibberish without the right key. A friend of mine works for a healthcare company that was sorting medical data in S3 without encryption because IAM is already protecting it, right? That's like saying you don't need to lock your car because it's already in your garage, right? Layers, people, layers of security, okay? Next, multi-factor authentication is non-negotiable for IAM users who have human IAM users who have significant permissions, right? It's the extra step where you need both your password and a code from your phone or a hardware token, right? Yes, it's slightly annoying, but so is getting hacked, right? It's like the differences between a door with just a lock versus one with a lock and a deadbolt. Okay. I had a client who resisted implementing MFA because it was too cumbersome. 2 weeks later, an employee credentials were compromised in a phishing attack. Fortunately, the damage was limited, but it was an expensive lesson that could have been avoided with MFA. Then there is access logging with AWS CloudTrail. Right? This records all API calls in your account, creating a detailed audit trail of who did what and when. It's like having security cameras in your building, right? They might not prevent a breakdown, but they'll help you figure out what happened afterward. Here's a here's a real world scenario. A company noticed their machine learning training costs suddenly spiking. With CloudTrail logs, they discovered a data scientist had accidentally left several large GPU instances running over the weekend, right? Without those logs, they might have just blamed the cost increase on AWS being expensive rather than identifying the actual cause, right? Lastly, IAM Access Analyzer is like having an automated security consultant reviewing your policies. It identifies resources shared with external entities and helps you find overly permissive policies. It's like I like to run it periodically, like a security checkup for my AWS accounts, right? All right, another quick story. I once used Access Analyzer for a new client and found an S3 bucket containing sensitive data that was accidentally made public. The bucket had been public for months, but nobody knew because nobody was checking, right? It's like discovering your back door has been unlocked all winter. My God, what a chilling realization, right? Remember, security isn't a one and done. Security isn't just a one and done. Slide 8, IAM pitfalls to avoid. All right, now let's talk about some common IAM mistakes that I've seen repeatedly in the wild, right? Consider this your what not to do guide, as I like to call it. Learn from other people's painful lessons, right? Instead of having to experience them yourself. First up, overly permissive IAM policies. The security equivalent of using a sledgehammer to kill a fly, right? The AWS managed policy administrator access is like the nuclear option of permissions, okay? It grants literally every action and every resource. I've seen it attached to roles that I only needed to read from the single S3 bucket. So just be very careful, right, with the administrator access. A friend was consulting for a startup from where every employee had admin access because the CTO didn't want to waste time on permission issues during their growth phase, right? Fast forward 6 months, and they suffered a security incident where an employee compromised credentials were used to spin up crypto mining instances, okay? The cleanup cost more than it would have taken to set up proper permissions from day one. Next pitfall, hard-coded credentials and ML pipelines or code. And this is putting your AS access keys directly in your code or configuration files. It's like, writing your ATM pin on the back of your credit debit card, right? Convenient, but incredibly risky. I once saw a data scientist commit their AWS credentials to a public GitHub repository. Within hours, those credentials were used to launch expensive instances. The bill ran up to thousands of dollars before anyone noticed. Somebody was, crypto mining, I guess, right? And yes, this really happens. There are bots constantly scanning GitHub for exposed credentials, okay? So instead of hard coding credentials, use IAM roles for EC2 instances running your machine learning workload. Or assume roles in your Lambda functions, right? It's like having a hotel key card that automatically expires after your stay rather than a physical key that could be copied and used indefinitely, right? Another common mistake is ignoring policy conditions. Just allow you to add extra restrictions, okay? Well, like only allowing access during business hours or only from specific IP ranges, right? Skipping this is like having a sophisticated alarm set but never turning it on. For example, you could use a condition to only allow model training during business hours and prevent unexpected cost surprises from overnight experiments going wrong, right? Or you could restrict certain actions to specific to VPC endpoints, adding an extra layer of network security. The final pitfall to mention is not regularly reviewing updating your IAM setup. Just like I said in the last slide, security isn't a set it and forget it thing, right? Just like with compliance and regulatory work, you can't just do it once and forget it. It's more like gardening, requiring regular attention uh, to keep things from getting out of control. I recommend quarterly reviews of your IAM policies, rules, and users. Look for inactive users, right? Only overly permissive policies and any new AWS best practices, right? It's like changing the batteries in your smoke detectors. A little maintenance now prevents, big problems later. So key takeaways. All right, let's bring this all together. IAM is your security control for machine learning workloads. It is what it stands between you, your valuable data, and the wild west of potential threats. It's not just bureaucratic red tape, it's your frontline defense. The principle of least privilege isn't just a fancy security term, It's practical wisdom that can save you from countless headaches. And remember roles, right? Different ML task requires different permission sets. Encryption isn't an option in today's world, right? It's like table stakes. And you have to remember that encryption is needed both at rest and in transit, right? Logging and monitoring your security time machines, right? Letting you see what happened in the past so you can prevent problems in the future, right? And please, please, please avoid these common pitfalls we discussed. No hard-coded credentials, no admin access for everyone, no ignoring those helpful policy conditions, right? All right, so thank you for your attention today, and remember, in the world of cloud security paranoia is a disorder, right? It's like it's one of the places where it is a skill for you to be paranoid.